Right before I start? Okay. Because I do what I want. No, these are very comfortable socks. Somebody asked me why I wear ankle socks. These are very comfortable socks, and yes, I did buy them at Costco. You're probably thinking, oh, Mr. Adams has one pair of Adidas very comfortable Costco socks. No. Shout out to Adidas. I have so many socks. I bet you I have 40. I bet you I have 20 pairs of socks. 20 or 30 pairs. No, I take that back. I bet you I have 40 pairs of these Adidas socks. They're so comfy. They're real thick. They're real soft. They're really comfy. Anyways, let's talk about parabolas. So we just finished a section on quadratics, which means something is raised to the square root. A parabola is the shape of a quadratic. And so that's what we're going to talk about. So a parabola is defined by a set of points equidistant from a line called the directrix. I'm sorry, I mispronounced that. And the point called the focus. The focus will always lie on the axis of symmetry, and the directrix will always be perpendicular to the axis of symmetry. This definition can be used to derive the equation from the horizontal parabola opening to the right with its vertex at the origin using the distance formula. The derivations of parabolas opening in other directions will be covered later. So a quadratic equation is y equals x squared. What we're looking at right now is x equals y squared. So it's like the flip-flop. But in either case, all this information holds true, and we'll dive deep on that. So if we want to derive a formula for this, we have to do a couple of things, and this is a different way to approach it. But what I want to point out in the graphic here is that, let me get my little laser pointer. This vertical line is perpendicular to the axis of symmetry of the parabola. So this is the parabola right here, right? And then the axis of symmetry is here. The focus is here, right? That's a point. It's a fixed point. We call it P, comma, in this particular case, 0 because it's on the x-axis. But it's P, comma, some sort of value. And then the point on the parabola is equidistant from here to here and here to here. In other words, the length from here to here we'll call d for distance, and the length from here to here is d. Now, these values, how far the directrix is over, we'll talk about the relationship. And so we're going to derive a formula that kind of mathematically puts all these things together. So you're going to have a negative p-value, a negative p-value, a positive p-value, right? And that's referring to these x values, okay? So whatever this x value is, you're going to have that negative x value over here, all right? Whatever this y value is, you're going to have the same y value over here. The parabola is equidistant from this y value to this y value, and then the x value isn't necessarily the same. So that's how we get that parabolic shape, okay? So, and that's a mathematical relationship. So how do we derive the formula is where I'm going with this. So part A of deriving the formula, we have to know the coordinates of the focus. Now, the focus is like the center. It's not really the center because the center would imply that it's equidistant from all the points. It's not. This distance d varies. The distance from here to here is equidistant to this, but it is a shorter distance than from here to here. And as we go further out, the distance will be longer, but it'll be equidistant going back to the directrix. Does that make sense? So we can't necessarily call it the center. So one of the words that we call it is the focus. And that is always going to occur, well, in this particular case, we're going to assume that it's p comma 0. You can shift this up or down. You could where you place the parabola. So if it's at 0, the next thing we want to do is we want to calculate the distance. So to calculate the distance, we're going to use the distance formula. So the distance d is equal to, remember that the distance formula, I don't know if you guys remember this from Algebra 1, is going to be the square root of x sub 2 minus x sub 1 squared plus, that's a plus sign. Let me write it a little better. That's terrible. God bless you. Plus, what's the rest of this? Y sub 2 minus y sub 1. And you might say to yourself, wow, that looks a lot like how we calculated the radius of a circle. Yeah, it's the same formula, except we plugged in a y and a k and an x and an h, which, by the way, h and k are x and y values. Okay, and the radius is the distance from the center to the perimeter of the circle, or the circumference. So in this particular case, though, we're going to do that a little differently. The distance, we're going to compare this and this. So you could think of this as like x sub 1 comma y sub 1. And you could think of this as x sub 2 comma y sub 2. So if that's the case, I'm going to take the square root of in parentheses x minus p squared plus y in parentheses minus 0 squared. Okay, so that's the second step to derive this formula. Okay, then for step C, we need to identify the distance from the point by drawing a perpendicular line segment. So this line right here that we're about to draw, this line is parallel to the line of symmetry, but it is perpendicular to the directrix. So we go to the directrix and we draw a perpendicular line until it connects to some xy value. Okay? And that point, whatever that is, we're going to label as negative p comma y. Technically, what we do is we go from this point and draw a line this way such that it's a 90-degree angle. Okay? And then the next step is we're going to solve for the distance, because we're saying that it has to be equal, right? So the distance is the same, but now if this is x sub 2, y sub 2, except we kind of reverse it, we're going to let this be x sub 2, y sub 2, and then this becomes our new x sub 1, comma, y sub 1. So in that case, I'm going to say x minus p squared plus y, right, minus y squared. Okay? And that's an interesting dynamic. So now, this, for part E, d has to be equal to d. In other words, my square root of x minus p plus y squared, right? I'm going to simplify it because y minus 0 is just y squared. I'm plugging this stuff in. That's the stuff here. That has to be equal to this stuff here, because they're both equal to d. So then I'm going to say the square root of x plus p squared. What's y minus y? What's this become?
0.
0. And 0 squared is just 0. So that's it on that one. So now I've got to do some math, and we're gonna manipulate this a little bit. So I'm gonna go to the next slide. So I'm running out of room on my little thing here. So whoops, I need to. How do I do that? I'll just write on the other side. So if I move over here, you guys have to make that same sound. So if I square this, and I can not square that, that's the wrong place to put it. So if I take this and I square it, and I take this and I square it, when you square a square root, you're left with just the base. So I'm going to have all this stuff that's stuck under the radicand. In other words, I'm going to have x minus p squared plus y squared is equal to x plus p squared. Does that make sense? Now, one of the things that I could do in this particular case is actually square these things out. So x minus p squared, this whole thing right here, and so let me just kind of show you what I'm talking about. This whole thing right here, if I come over and I say x minus p times x minus p, which is squared, and I do all the math, that actually becomes x squared minus 2p minus, or actually plus p squared plus the y squared. And then over here on this side, this becomes x squared plus 2px. I'm sorry, I forgot to put, there's a x here. 2px. And then this is 2px. And then plus p squared. So now I need to start isolating some variables, right? So if I subtract x squared from both sides, what happens? They cancel. So in my next line, I've got negative 2px plus p squared plus y squared is equal to 2px plus p squared. All right, well, if I subtract p squared from this side, and I subtract p squared from this side, I get negative 2px plus y squared is equal to 2px. Now, if I want to solve for y squared, I'm going to add 2px on this side, and also add 2px on this side. And I'm going to get y squared is equal to 4 times p times x. So that is the mathematical relationship of a parabola, okay? Based on knowing where the focus is located. Based on knowing the value for x and the value for y. Does that make sense? So it really simplifies down to this equation. So we're going to basically use this equation a lot. Deriving formulas is an interesting thing for me. It's one of those things that when you derive the formula, you're like, why didn't they just give me the equation? And then only when you start deriving formulas, you realize, like, I don't need to memorize the equation if I learn how to derive it. It's a weird thing. Anyways, that's the equation that we're going to use a lot of. All right. So let's move on to an example. So what does all this mean? Well, if I flip this, this was a parabola that was turning sideways, right? So we just solved for this, and that was a horizontal parabola. In other words, when we graph it, it looks like this. This is what they mean by a horizontal parabola. It looks like this. But when we graph a vertical parabola, notice that we have y times 4 times p equals x squared. And that's what you guys are used to, right? That's what we just talked about, is it looking like this. Oops. It's really difficult to draw vertical lines on this thing. Okay. And so here's some key things that you guys should know. That if p is a positive number, right? So if p is positive, that's a fancy way of saying p is positive. If it's greater than 0, then it's going to open up. So my graph will open up. And if it's positive and it's horizontal using this equation, it will open to the right. Now, if p is negative, then we know this too. It will open down. We're kind of used to this. Now, if it is horizontal using this equation, it'll open to the left. The focus is always going to be, for a vertical, it's going to be 0, comma p. For a horizontal, it's going to be p, comma 0. So I'm not going to derive this formula, but if you take that parabola and rotate it, or I should write it or show it to your perspective. If you take it and rotate it, the p and the 0 kind of flip-flop because you're flip-flopping the x and y values. The directrix, in this particular case, for a vertical one, you're going to have your parabola like this, and then the directrix, which will be the blue line, will be over here. And then your focus, yes. Yeah, that's on page 176. So that little graph is on 176. You don't have to write the table out. It's in page 176. I'm gonna give you guys enough homework problems that you should kind of know this. But if you write this, at some point in time, you're gonna need to know this information on a test. So you can write the table out. You don't have to write all this paragraph stuff, just the table. All this stuff up here is explaining the table. If it's a horizontal, the directrix, which is a straight line, will be on the opposite side of the graph. So a horizontal parabola will open like this. And remember that the focus will occur over here somewhere. And this is the focus. So I should do that with green so it kind of color codes. And then the axis of symmetry, whatever this value is, the axis of symmetry will be, let's use a different color. The axis of symmetry will, in this particular case, has to be a vertical line. And as you recall, a vertical line is x equals a number. And in this case, the axis of symmetry will be a horizontal line. And as you recall, that'll be y equals a number. Okay? And then we'll change those values for 0. This only works for 0 right now. This only works for 0 because when we use 0, the things kind of cancel. Well, it's not true. It works for other things too, but we'll just focus on this for right now. Okay? So then what does that mean? Well, let's do an example problem. So I had to do all that stuff. Do you guys have this kind of jotted down? This was page 176. Is it 126? Did I read it wrong? It's 126? Huh. So weird. All right, cool. Yeah, if you want. Guys, this is in your Jamboard notes too. So you could just go to Jamboard notes and write it down if you want at some point in time. Okay. So I am going to move on to the next slide. We're going to do an example problem and kind of think about it. So for example 1, we have a focus of -8. Oops, I had that upside down. That's funny. we have a focus of, let me do a different color, a focus of negative 8, 0. So that's going to be right here, negative 8, 0. And the directrix is x equals 8. So that's here. And the vertex, so this is an interesting thing too. We didn't really talk about the vertex. The vertex is the vertex of the parabola. Remember that the vertex is also on the line of symmetry. So in these scenarios, our line of symmetry is either the x or y axis. So my line of symmetry or axis of symmetry goes through the focus and the vertex. And in this particular case, it's x equals 0. And that all comes from that table that you guys just jotted down. So because I have this information, first of all, what type of parabola is this? Well, it's horizontal, right? By looking at the graph, I know that it's horizontal. And so what do we know about horizontal parabolas? Parabola. That's the first thing we know. Well, we know that they have oh wait. We know that their focus, so let's write this down. Their focus, because it's a horizontal parabola, will be P, comma 0. Okay. We know that's their focus. We know that their directrix, in this case it's written down in red, will be x equals a number, right? What else do we know? We know that their focus, and what is that number? So let me write this a little more formally. Because, and I'm going to bounce back so you guys can see that. There is a relationship, right? So on a horizontal, x equals negative p, right? So I have p comma 0, so x equals negative p. I'm just getting all this information from this table right here. Oops, let me go back this way. So x equals negative p. Well, what does p equal in this particular case? Well, p equals negative 8, right? So I would say that p equals negative 8. So then my directrix x equals negative 8, which equals 8, right? So that checks out. The vertex, did we have any information about the vertex? Not really. We'll talk about that, but most of the time, well, I shouldn't say most of the time. Like we'll unpack that in a second. But we can confirm that the vertex is at 0, 0 by the graph, okay? I will say this, though, about the vertex. Well, I'll just type it. I'm typing it so you could see it better. The y coordinate of the vertex is the same as the focus which in this case is 0. So whatever this y value is, in other words, if I think of this in terms of being an x comma y, my vertex, which occurs on the line of symmetry, okay, it's going to be this y value of 0. Now, the line of symmetry is based also on the focus, okay? So what that means is that the x-coordinate of the vertex is halfway between P and negative P. And so what is P and negative P? Well, that would be, what's P? Negative 8 and 8. Well, what's in the middle of negative 8 and 8? 0. So then my vertex occurs at 0. Okay, so before we move on, we're still not quite doing example 1. I'm just kind of laying out all the information. We're going to actually try to figure something out based on the information that they give us. Okay? You guys have this written down? Even as I'm teaching it to you, it seems very complicated to me. But once we lay down the foundation, it's going to be real easy. I'm going to say, this is the focus. And then you're going to, oh, this is the equation, this is the thing, this is a, I'll give you like, this is the focus, and this is a point on the parabola. And then you go, well, I know what P is, I know what X is, I know what Y is, I plug it in here, I can find this, I can find this. You'll find all that stuff. But we have to kind of prove, in math, we have to prove that this is a consistent thing every time. Okay? Yep. All right. So now, let's do this. So it says that the focus 0, 2, 0, negative 2 occurs. All right. So this is the information on a parabola. All right. Well, immediately I'm just going to start labeling things. So I know that P is negative 2. Because it's 0 comma P, if I go back in the table, I know that it'll have a horizontal directrix, right? Because remember that your directrix is going to be x or y equals negative P. And since I have a P here and this is 0, okay, then it's going to be y because my P is in the y coordinate. If I had a number here and a 0, then my P would be an x coordinate, and it would be x equals negative P. Does that make sense? So that means my parabola is vertical. All right. And this is confirmed that the vertex is in at 0, 0. Okay. So let's do that. How do I confirm that? Well, we said that the y coordinate was, how did I word that? The y coordinate for the, so let's talk about vertex. The y coordinate is equal to the focus. Okay. The y coordinates the y-coordinate of the vertex is the same as, wait. No, it's not the y, right? Because this is a vertical one. So the x is the same as the x value of the focus, right? So that would be 0. Now, in this case, so we're flip-flopping it. So now the y-coordinate is halfway between, boy, that's a horrible handwriting. P and negative P, which is 2 and negative 2. What's halfway between 2 and negative 2? 0. Okay. So then our vertex is going to be an x comma y value, or it's going to be 0 comma 0. And if you're wondering what this graph would look like, now we could take this a step further and actually graph it. So remember, and you have to look at the table of values. Well, let me say that. Let me show you that. So I know this off the top of my head, but when you guys go to do your homework, you're going to look at that and you're going to say, oh, this was 0 comma p, it's vertical, so all this stuff applies. For example, we said that the directrix was y equals negative p. We said that the axis of symmetry is x equals 0. And then if p is positive, it'll open upward, or if p is negative, it'll open downward. So let's start applying those properties. P is negative, so what does that tell you? P is, it's going to open downward. Okay, what other information can we get from that table? P opens downward. This axis of symmetry is x equals 0. So let's write that down. Axis of symmetry, x equals 0. What else? Oh, here's the equation. Here's the equation. So the equation then for this is going to be x squared is equal to 4 times p times y. Okay? Now, if you plugged in 0 for x and y, you would find out, well, let's figure this out. So I know that x squared is going to equal 4 times p is negative 2, times y, or x squared equals negative 8y. All right? So if I wanted to graph this thing, I could come up with a table of values, right? In other words, I could work backwards. I could plug in a value for y and get x squared. Now, one other thing I want to show you, and then we'll double check with the answer in the back of the book. For these types of equations, unfortunately, we can't use our graphing calculators. You have to use Desmos. But it's not a bad idea to plug it in. So I said that x squared is equal to negative 8 y, correct? Hey, looky there. What did we say the we also said that the directrix was y equals 2, correct? We also said that the focus occurred at, what was the focus? What did they tell us? 0 minus 2, right? Okay. Okay? And let's pick a point on the grid. Let's pick this point here. I think that's 4, 2, right? Yeah, 4, -2. So let's just graph that. 4, -2. And we're just going to label this as an x, y. Okay? So I'm going to take a screenshot of this, and then we're going to do a little math and see if it works. So this is what I have. Let's put it in here. So now if this is true, the math should work out, right? So I think I've done everything right. Let's see if this is true. So this point here, we said that this point was 4, -2. So when x is 4, y equals -2. Or I could say, if my equation is x squared is equal to -8y, I could say 4 squared should equal -8 times -2. 16 equals +16. It works, right? It works every time. And one of the things that we're not necessarily mentioning is that the distance from here to here is going to be 4. And if I measure the distance from here to here, guess what? If you count it, it's actually 4. And that'll be the same every time. And then lastly, keep in mind that this line is perpendicular to the directrix. So this is your directrix. Everything I'm writing down, you guys should be writing down. Right? We said that we had a line of symmetry. Whoops. That wasn't a line, that was a scribble. Well, I'm doing the best that I can. I don't know why the vertical lines are so hard. So this is x equals 0, and that's the symmetry. Right? The focus was right. And if I pick any points on a line and I draw a line this way to the end and this one here, it's going to be the same every time. Okay? Does that make sense to you guys? Okay. Well, it might not make 100% sense. It's the first time you've probably ever seen this in your life. It's probably a lot to take in. But you could see that there's no mistakes or errors, right? Yeah. All right. By the way, this is the graph in your textbook. Let me take a picture of it. So yeah, we did the work right. Does that make sense? So when you go to do your homework, you're going to need that table. You're going to look at that table. It's going to be instrumental in knowing what to do. You're going to either have a vertical or a horizontal thing, and you're going to just keep repeating that process. I think this is the one thing, if I need to teach you anything, is how to use the information that I give you to help you get your homework done. So when you go to do your homework, immediately have this in front of you. They're going to give you enough information somewhere that you can use to identify if it's vertical or horizontal. And then you start plugging away and start chipping away at all these things. Well, the directrix is this, the axis is that, and it's going to be different, right? Somebody's going to make the mistake and say that the directrix is x equals -p when it's a vertical, and it's going to confuse them, and it's going to make the math off. You've got to just, that's a decision you have to make based on the information they give you. And you're going to need that right in front of you. You can't do it off the top of your head. You haven't learned it yet. So when you go to practice it, now over time, I'm going to give you enough homework problems so that over time you'll go, oh, it's a 0, p. That means that it's going to be a horizontal directrix. That means I'm going to have a vertical parabola. But until then, use those notes and look at them. Okay. I'll leave that up there so you guys can